Good evening. It's Tuesday evening, 10:30 in Alberta, and I still haven't got the parts that I'm waiting for to continue on with the bench hand shaper that I'm trying to build. So I've already done one fill in, and so I thought I'd do another one while I'm waiting. This one relates back to a video that I did on the new tailstock that I attached to the TIG lathe, and it consists of a sliding block. It consists of a sliding block that locks anywhere along, and I used the design of what was his name now? He built a lathe, and for the modelling fraternity, and he had a special patented key he had for aligning the tailstock and the lathe, because it moved up and down on a big column. What was his name now? Mr. Oh boy, I mentioned it in one of the other videos. I don't know, I'm just getting worse and worse. Anyway, it's like a wedge key. It's shaped like a triangle on the end, and it goes into a key, a dovetail slot that I milled in the back here. And the reason that I had to do that was my original design was to use a bar, a square bar, 1/8 I believe, as a keyway, and a slot in here to guide it. But it was too difficult. It has to be really good to be consistent, and what happened was that it developed, because of the clearance not being really accurate in sizing, it allowed this block to rock backwards and forwards on the bar. So I had to make this wedge up. This is just a pin with a eccentric on it, and when you turn it like that, the eccentric pushes this wedge into this groove here, this dovetail groove, and locks it up solid. There's no rock whatsoever. Okay, so I did this video, and it's MVI 0009, and it was back in May 2013 that I got it to the stage where I was testing it for drilling, and I used a 7/16 drill and drilled directly into a 1-inch aluminium rod or slug, and with no pilot hole or anything, straight in. And what happened was that this is the part that goes. This is the part that goes on here, and this is the new tailstock, you see. So that tailstock slides on the dovetail here and dovetails under here. And because of the distance between this bar here and the center of the lathe bed, this really wasn't wide enough. This should have been wider, much wider. And so I was getting every time I was pushing the drill, this unit, the unit that slides on here, would flex by at least 8 to 10 thou. At that time, the reason for that was also the fact that at that time I had a female dovetail going onto this, sliding onto this male dovetail, and it was solid, so it had to be good fit, and obviously it wasn't that good because there was this flex whenever pressure was applied on the plug. So what I did was you might be able to see it this way. On this side here, these two plates here are screwed and doweled on, and originally they were two identical plates either side for the fit, and of course being doweled, once it was doweled you were kind of losing a battle because everything was locked up solid. So what I did was I milled out a section on this side and put in two little thumb screws and inserted a brass triangular key in there. So before I used to slide it on and just put a screw down through here and thread it into there, and of course it allowed everything to move. So with this design here, with this new design, I can now slide it on and slide it off easy and just nip these two thumb screws up, and that locks it solid on the dovetail. So that eliminated that situation. So as you can appreciate, the quill of this unit has to be at right angles to these dovetails, and I found that that when this was locked onto there, I would get a discrepancy. The center would wander the further that it came out. Well, it was only maybe 3 or 4 thou difference, and it didn't really matter if I was drilling center drill. The center drill would usually find its own center, and then a drill, it wasn't that bad. But since I've waiting for these parts, I decided that I'm going to try and do something about it and get this accurately parallel to the lathe bed. So that's the idea of this video. It's not going to, the video is not going to be finished in this session, I'm sure of that. But what I'm trying to do is I'm trying to show you that the first thing that I have to do is to go back and check these uprights and the round bar, the guide bar, to make sure that it's parallel and vertical and horizontal within the length of the lathe bed. So that's what I'm doing at the moment, and I thought I'd just let you see exactly what I'm doing and the process. So I'm hoping that you can see this dial indicator here. Let's get my flashlight. Where's that now? Where's my oh, there it is. Now I don't know if this is going to work or whether it's going to be too shiny, but this is the dial indicator, and I'll try and hold it on there as I push this along. So you can see where the pointer is it's on the figure, on the number 10, numeral 10. So I'm pushing this along as far as I can go, and as you can see there's probably half a thou run out on this plane, on the top surface. This is pretty solid. I'm quite surprised. This is really quite very stable, considering it's on two little dovetails on the extrusion of the base of the lathe. So I'll just wriggle it a little bit, and then I'll wind it back, and as you can see, I hope, that's pretty good, I think. Now if I wobble that, you can see how much movement there is. If it's half a thou, that's about it. That's using quite a bit of pressure on there. So I can guarantee then that this first test that I'm doing is okay. I'll switch the light off now, and now I have to readjust the stylus, and I'm going to come down like that. Now I can't get to the high point here, and I can't even get to it on that side because I've got the dovetail groove at the back here, and I've got the brass key in here. So I'm going to go on to because this is pretty level within half a thou, I'm just going to get it down as far as I can, close to the key, the brass key, the square key, and that's good. And we'll just put a feed on, and we'll go to the 5. Okay. Now I'll just rock that backwards and forwards a bit now this is where I have the problem, I believe. That's pretty close to the end. That's on the, that's there we go. That should be. That's on the 5. Okay. Now, flashlight again. Now this won't be a true reading because it's not in the vertical plane on the center of the bar. But it's pretty, it should be, give a good indication, and you'll probably, I hope you can see this. You see how that is running? Now I think that that's pretty good. So I'm pretty confident in saying that the guide bar for the tailstock is pretty accurate. I mean, nothing's ground. It's all machined. Even this bar is just a piece of drill rod, and this is drill rod. That's drill rod. This is aluminium blocks, 2 aluminium blocks, and I've got it adjustable, as you can see. I've got some little shims underneath that dowel, and that dowel there, I had to do that because I was slightly out, but it's adjustable. I can undo the screws there, and I can tap the bar up or down, and that's how I lined it up by the use of the lathe bed. Okay, now the next thing that I have to do is to, let's see, take this out. I have a little ball bearing. You can see that little screw there. Let's see. What I have is I decided to add this as a little feature, and as I made the tool holders, don't know if you can see that. There should be a little ball in there. I've got a ball bearing in there, and an adjustment screw there that compresses a spring up against the ball, and it's tight enough. What did I do with that now? See, I've forgotten where I put it. Oh, here it is. Yeah, so I made it so that this arm, adjustable arm, would pop in there, and the ball bearing would keep it nice and snug, so I can twist it around. Just a little feature that I added that wasn't on the originals. So I've got that now. I'm sorry if this takes too long, it's long-winded, but like I've said before, I'm not very good with the camera. I'll put that in there and just nip that up. That's all that needs. I think this is how I did it. I've already checked the quill in the let me take that. Small lathes, small machines, always very fiddly, not like a big lathe. Let's see if that will go. And do that. Move that back. No, it's got to go that way. That's right. Okay, now I'll put the column up. Let's take this off. Another, it's just a simple little tool set. That's basically it, and the holders. Works very well. Okay, now we'll slide that on there, and I have a, I'm hoping it's going to be pretty close. I have an adjustment, I have whatever. I can't even remember that. So it should make contact with the spindle, and then I just nip this up, okay, and lock that up, and that makes everything secure, no up and down movement or anything. So that's that. So we know that this bar is pretty good. Now it's a case of dialing in the quill, and I'm not going to use the taper. That taper, what I did there, I bought what they call wow, a repair sleeve, and it's got a one. It was made in China. I mean, obviously most stuff comes from China. It was a, oh, I can show you. Okay, it was this. Now this is a sleeve, a repair sleeve for drill. Oh boy, what's happening? Oh, it's okay. And it's got a 1 Morse taper machined in there. So what I did was, I know it's a big chunk and it's nice material to machine, and it's got this the drift hole slot there. I put a dummy Morse taper that had a taper at the other end for a drill chuck, but it had centers on it, so I checked it first to make sure everything was true, and I put that in there, and this has a center at this end already drilled in, so I used both centers like a fixed center, and I did that with the top slide at a 30-degree angle, so I knew it was running true with the spindle. And then I used the TAG unit at Tailstock at this end, and what I did was I machined this outer diameter down between centers, and a Jacobs, nice hardened Jacobs Morse taper 1, and I machined it down to a size that was, I can't remember the diameter now, but it was small enough to go into, this is a cast iron bar that I bought, and I bored this end out to fit the finished size that I had on this Morse taper insert. And then of course once I'd done that, it went in and I locked it in with Loctite. So I didn't mess around trying to make a 1 Morse taper. It was $4 plus shipping from China. I forget what it cost me, maybe $14, $15 with shipping. So that's what I did at this end. Okay, so now that I know that bar is parallel with the lathe bed, I've now got to dial this quill so that it's in line with the center, and then I've got to check it at different positions to see. I'll check it here first, right up in the block, and then I'll move it out, and I know that if I don't unscrew this after I've dialed it in, I can move it along there and I should get the same reading up at this end. If I don't, it means that this is not exactly in line with the dovetail, so I may have to do something with the dovetails. I have held a dial indicator on the cross slide and took that out to that extent, about, I don't know, 2.5 inches, 3 inches, about 2.5 inches, and run the dial indicator along this face with the dial indicator on the bed. So, and it's out about 2 thou, 2 to 3 thou. There's a difference. So this is what I'm trying to determine now, how to go about in eliminating this small run out at this point. So that's the reason for this video. I just felt that it wasn't completely finished because of this actual run out. If I was doing anything between centers, I'd have to put a test bar. I have a test bar here somewhere. Here we go. Here, this is a test bar that I did, and it's running. It's pretty parallel. Not the greatest finish, but it's pretty good. And so if I'm doing anything between centers, I have to, once I've set this to the right gap, then and check my test piece, then I can't move this anymore, or I can't move this quill anymore. It has to stay in one place. I can only wind it back to take whatever I'm doing out and put it back, and then, but I can't move this complete block. So that's the situation at the moment. I'm going to wind this back down to here, and oh, I know what I used. Yes, I know what I use now. See, I use things half hour ago and then I forget. There. Now what do I do with that? Here? Yeah. I bought this unit last year, I guess, or beginning of this year, and it's come in very handy. It's a gem that clears. Yeah, it's a gem dial indicator. An old thing, but in really nice condition, and it's ideal for this kind of thing because I can read the dial at the top, and when I get down to the bottom I can read the other dial because it's a double dial. So I'm going to use this. Okay, I'll undo that and I'll move this along until I get a reading, and now, I mean, obviously the distance from there to there, you're going to get some movement, and oh, let's get that out, look that up, and see, it's pretty stable, but whenever you're putting any pressure on, it's going to move backwards and forwards, you see. So I have to see what I've got. Let's take a look. Okay. Okay, that's on 10. So when I revolve this,